There is no other place on the planet that honors aviation history more than the National Museum of the United States Air Force, located right here at Wright-Patterson Air Force Base. It is the oldest and largest military aviation museum in the world. The museum sits on more than 19 acres of indoor exhibit space and features more than 350 aerospace vehicles and missiles. Make sure you add this site to your next on-site trip to Dayton. Trust me, you will not be disappointed. I hope you enjoy this next panel discussion.
Good morning, everyone. I'm Chris Sharwoff from Sable Systems. I'm a managing principal for our practice that does digital engineering, Internet of Things, and several elements with Industry 4.0. Our panel this morning is going to cover a variety of topics related to industrial control systems and utilities, and how to enable them at the edge, protect them securely, and how to induct new technologies and architecture paradigms into the solutions. What's fascinating about this environment, and I've always loved this piece of our industry, it's been relatively static for several decades in terms of how you implemented industrial control systems and powered utilities. But with all these fascinating new technologies, there are so many opportunities to not only better utilize the technology that's in place, but also generate more value for the organization. With that in mind, we've actually assembled a diverse panel of multiple perspectives from both industry, large business, small business, as well as government. And I will have each one of my panel members introduce themselves briefly, starting with Alexander Avid.
With the Air Force Research Lab Information Directorate in Rome, New York. I have more of a tech advisor type role, and we've got a number of programs in our branch dealing with critical infrastructure systems and targeting. So that's just a brief introduction, but we're working with a number of government agencies and other Air Force bases looking at rolling out, critical infrastructure systems, looking at how they can better apply updates, how we can, better quantify what infrastructure we have on our bases, what the cyber threats are, what the attack vectors are, and how we do the matchmaking for the people on the bases, the engineers that need to maintain those systems safely, that need to maintain and patch them. And then that dichotomy between needing to patch systems and change working systems and, versus not wanting to touch them and understanding what the cyber threat footprint is.
Thanks, Alex. Jordan, Garrett, would you like to introduce yourself? Hopefully we're going to switch over to Jordan.
My name is Jordan Garrett. And forgive me, I'm having a little bit of technical difficulties, but I'll attempt to give my introduction. Dell Technologies lead for digital twin edge solutions for our Dell public business, working with our partner ecosystem to build solutions so people can adopt digital twin technologies, begin to push capabilities further out to the edge, specifically in the sense of the public sector, to help the warfighter and those who sustain warfighters be able to deliver new capabilities, better, faster, cheaper, more efficiently, for better outcomes to the individual.
Mr. Todd Edmonds.
Hey, great to be here. Thanks, Chris. Hi, everyone. I'm Todd Edmonds with Dell Technologies. I'm the Director of Industrial IoT and Edge Strategy, as well as developing our strategy and solutions for digital twin. I work a lot with Jordan and Garrett. I've been doing this for quite a long time, working. I've been with Cisco, I've been with Rockwell Automation, Allen Bradley. I've done it from an integrator point of view. So I have a really good perspective on how we deploy the next generation of smart manufacturing and industrial IoT applications, as well as what we're doing with digital twin.
Anusha.
Yeah, thanks, Chris. I'm Anusha Iyer. I'm with Corsha. I'm the CTO and co-founder, and it's a cybersecurity startup in the authentication space. What we've done is come up with a way to do multi-factor authentication for machines. So machines at the edge, IoT, industrial control systems, microservices. My background is heavily on the cyber side. I've been in and around the government space, including the Naval Research Lab and managing various DARPA programs in the areas of cyber mission planning, security, privacy, and so forth. And I'm excited to be here today. Thanks.
Good morning, everybody. My name is Mike Ukis. I am the Government Engagement Manager for MXD, home to the Department of Defense Digital Manufacturing Institute and National Center for Cybersecurity and Manufacturing. We're actually home to the first 5G testbed that's affiliated with DoD outside of a DoD installation. So we're actually very proud of that, and we're working with a number of partners to kind of leverage that for the benefit of the department, especially as it relates to some of our government partners, whether it's DLA, the arsenals and shipyards, and kind of all the service labs. Our role is to accelerate the adoption of digital technology on the factory floor, not just for small manufacturers, but also for those places like Rock Island Arsenal, where you find a 125-year-old building and manufacturing, dating back to forever, right? In a former life, I spent 16 years in the Air Force as an Arabic linguist and intelligence analyst at NSA, and it was actually kind of cool to see the video of the Air Force Museum, because I've been there, and it's a pretty neat place. So I'm happy to be here.
And with that, we'll step into our first series of questions. The first question will be for Todd. What types of design approaches are you seeing for industrial control systems and IoT, given their evolution of the technologies and the changing of paradigms?
Yeah, great question. And I'm sure it's no surprise. A lot of the conversation in these last couple of days, I've been focused around edge computing, and really it's really hot, but it really answers and helps a lot of the challenges that we've seen in industrial controlled systems and industrial IoT. The industrial control systems themselves sometimes are getting a little bit virtualized, but mostly they're staying the typical type of control systems, hardened devices, hardened control systems. But what really is changing is that approach to industrial IoT and building a data layer over the top of those control systems, let them do what they need to do, get that data out of them. And that's really, that what we're talking about, distributed edge computing. For Dell Technologies, it's really helpful when we talk to our customers to divide it into two things. And an industrial edge, where you have hardened edge compute devices that can go out in the field, that can go on the shop floor, that can go in vehicles and aircraft, and collect that sensor data and do the transformation of that data, where it's coming from, where it lives. And then building on top of that an enterprise edge infrastructure using modern IT grade, enterprise grade infrastructure over the top of it. It's no surprise that the data right now is residing mostly in those core data centers. 70% of the data is typically inside the core, but Gartner estimates in 3 to 4 years, 75% of that data is going to be coming from and being acted on at the edge. And so what's really driving that then is those next generation of applications for the industrial IoT, really to be much more efficient and get more out of the assets you already have. Applications like just simple data aggregation and transformation. It doesn't make sense in most cases to send all that data to the cloud. You need to do something with it locally and act on it quickly. And when you do go to the cloud, you want real quality data. So you use some of that enterprise edge compute power to really transform that data. But then we can start talking about the next generation of applications, things like advanced analytics and AI and machine learning, that are possibly the models being created up in the cloud, but being applied at the edge and needing that compute power to do that. Add in computer vision for some, industrial inspection or quality control or thermal vision even. You need to have that compute power where that's going on. It's not necessarily something that can live in the cloud, and add in containers and microservices so you can move workloads and data anywhere and write application once, but you need to manage that on the edge. And then we start talking about digital twin and digital thread, near and dear to our heart as well, and even 5G and the next generation of communications in a plant, outside a plant, and the capabilities that that's going to enable, but it's still going to require some on-prem compute. So we're really seeing that focus on distributed edge compute in two ways: the industrial edge, hardened devices, and an enterprise-grade edge that's going to need to aggregate that data. And then the second point is really that compute becomes much more diverse and it becomes much more accelerated. So you're going to see a lot more of newer, not just the GPUs and the FPGAs at the edge to do, the analytics processing on video, but we're starting to see some powerful AI-based chips like TensorFlow and neuromorphic, which really emulates the neural structure and function of the human brain. And we're going to see those start to appear and need to have a home on that enterprise edge out there in the factory or in the field where that's happening. And that's going to mean some new form factors as well. So those design approaches to be able to have hardened devices to host all of those. So that's really what we're seeing in terms of those design approaches.
Cool. Thank you, Todd. Next questions for both Jordan and Todd. Given those design approaches, are there big differences or subtle differences between enabling for smart buildings, on equipment, weapon system tracking, or a digital factory?
I'll go first if you don't mind, Jordan. I think really the key here is what we're seeing. The architectures really need to be software defined. If you look at a lot of the architectures that have previously been a part of these type of implementations, they follow a Purdue model. Well, really, you turn around and look, and all of a sudden the Purdue model is 24 years old. It was really invented back when Windows 95 was first released. So we really need to start looking at a different way to do the architectures, to do the connectivity, and software-defined compute, storage, and networking is going to be key. We're no longer able to just throw up firewalls everywhere, to be able to just keep data from going anywhere. We've got to have the capability to seamlessly and easily share that data between that floor system, that shop floor or field system, and the information systems and the systems that need to see that as well at that level. And not ignoring the security part of it. Obviously, that's going to be critical. But with these new software-defined architectures and implementations, there's a whole new role and a whole new way of implementing security. Microsegmentation is one. So microsegmenting all the way down, dividing that network into distinct security segments all the way down to that individual workload level.
Yeah, and from my perspective, looking at this whole space is really driving more than ever closer business and IT convergence. So I think from the IT community, as these architectures are developed and then implemented, there needs to be closer coupling and understanding of the expectations the end users are going to have, what they're trying to do with that data, how you unlock all that value that's been sometimes siloed apart across functional organizations, particular units or groups, and allow that to now be released so that it can be accessed by these digital twin or smart capabilities that are going to be enabling more efficient operations of these entities and more value driven for the end users.
Thank you. So Todd, building off that thread you had on there on the business side focus, what do leaders need to think about in terms of their adoption of these technologies, in terms of people, process, and their technology investments are changing in their practices?
Yeah, great question. I think segmenting those the implementations into an industrial edge and an enterprise edge helps kind of bridge that gap between the IT and the OT side. But I think one of the things that, security is definitely something that needs to be first and foremost, and that really, that security is really no longer going to be a bolt-on. It needs to be deeply embedded, centrally managed security capabilities. A lot of AI work is going on in terms of that next generation of implementing security. And I mentioned it earlier, the microsegmentation piece as well.
Yep. So if you had to pick two pieces of infrastructure to put in place for IIoT, ICS, and utilities for performance, resilience, and cybersecurity, what two technologies would you pick, or elements would you pick? Must have.
The must have is next generation security. Just basically mention that, it's not bolt on. It's built in through and through, designed in from the ground up, from the get go, from the very first. And then secondly, really multiple storage domains, and that's kind of a somewhat of a new concept, but it's really, when you look at it, it really makes sense in that you've got really three storage domains, and you want to make sure that you take consideration of, because you have your traditional storage that we're all used to, spinning disks, flash disks, etc. And those are like the traditional, what you see normally in a data center or even at the edge. But then we start to see a couple of different storage domains emerging, like an enterprise integrated storage domain, kind of a hybrid, cloud managed and provisioned, but you store it one place and it's really available almost anywhere you need it, right? Under the right circumstances with the right authority. But having a cloud, any cloud multi-blended capability for that enterprise integrated storage. And then the third type of storage that's really important is to have the high performance storage. So if you're doing analytics and provision, you're going to need that kind of storage that's very high performance, much more expensive. So you've got to make sure that you have a storage infrastructure that understands the different types of storage and where to store in long term and where to store the short term. But that high performance storage capability is going to be really, really key. Part of that, as well as the hybrid cloud strategy, is so that if you are going to store it on-prem, if you are going to have that hybrid storage, you need to have a hybrid cloud strategy, so that if you're working with this vendor or this particular device, it needs to have the storage in the Azure cloud, and this one might need to have it in a secure cloud, and this one needs to have an AWS cloud. But make sure you build that into whatever industrial IoT, digital twin, smart manufacturing initiatives you're having.
Thank you. We're going to switch over to Anusha and Michael. So one of the themes that a lot of customers sort of struggle with, and particularly the defense customers, is there is a difference between your third-party service providers as well and your organic employees. So what are some of the drivers that provide that remote access to IoT and industrial control system? And then what rules and controls are you seeing placed on third-party providers as part of the mission support?
I would defer to Anusha on this one specifically, because the folks in my world, if you go to any of the arsenals or in the organic industrial base on the Army or the Navy side, everything's air gapped to the umpteenth degree, right? So there is no ability to remote anything. I think the challenge we face is that IT policy and OT policy are usually separate things. And so any changes going forward, you have to figure out a way to integrate that. Otherwise, your newfangled widget's not going to work.
So I'm going to pick on you a little bit on that, Michael, and not to put you on the spot, but what are they forgoing by?
I defer.
Right. I know you did. I know, but given your example of that IT/OT barrier, are those customers seeking solutions? And then I think it'll dovetail a little better into Anusha's response. Do they see the need, want the need? Or is it they don't have the need and not really trying to drive a substantive change of how the architecture is managed?
I think it varies. There are examples I can think of, like Rock Island Arsenal. Their paint line is entirely manual. There's no reason from their own perspective to digitize that or to automate anything and introduce any real digital technology other than a signal saying we're done painting.
Yeah.
So there is a want, though, among manufacturers in the defense industrial base or the organic industrial base on the military side to implement the most up-to-date technology on the factory floor. The challenge they face, I think, is what they want and what the infrastructure behind them can support, because they're in a lot of old buildings and they're dealing with a lot of, when was the last update at Rock Island? In like 1995 or something, right? So there's a desire to be at the cutting edge on one hand. On the other, I think the challenge is, again, those policies aren't integrated. I think to Todd's point earlier, he briefly mentioned building in security and building in from a design standpoint from moment one. I think that will force DoD to kind of adopt certain standards and to progress and accelerate on the digital side a little faster, because you can't buy this new machine. You can't get the CNC machine without this built in. Because right now they buy it and it's got some sort of software package and integration with the internet, and they just turn that off. So eventually it's going to come to the point where, well, no, the only way this operates is when it's integrated and it's safe and it's protected. If it's sitting there by itself, it's just a $2 million hunk of metal. So I think that there are some avenues going forward for folks on that side. There's a desire to be at the front edge, even on the, on the policy side. But again, there's so many disparate issues when it comes to IT and OT, when you look at it, that it's going to be a real challenge to coordinate all that. You could go to Rock Island Arsenal and you can go to Crane Army Ammunition Activity. They're within Army Material Command, but when you look at where they're at structurally, those are two different IT teams that govern all that. And some say, yes, they think it's a great idea, let's do it. And same guy, same position, different base. And they're like, yeah, no, thank you. So.
Yeah.
Anisha? I would, so I'll kind of piggyback onto that. Certainly, I think the most obvious drivers today for remote access, and maybe this highlights the difference between IT and kind of the traditional, what we view as IT roles, and kind of OT devices and networks and infrastructure that we're supporting, is most obvious is patching, applying security, functional updates, obviously another is configuration updates. I think the burden that ends up falling on IT staff, as Michael alluded to, is with OT equipment, with industrial control systems, ends up being quite a variety of devices, software stacks, hardware stacks, that oftentimes it does make sense to have the vendor come in and apply the patch, right? And so there may be essential drivers for allowing that remote access, but that's not to say that it can't still be intentional, right? And so, what are ways that enterprises, organizations can kind of scope and limit this access, understand the impact? Certainly things like, policy-based mechanisms of having service providers request access into a network for specific functions and ultimately to a device. As Todd was mentioning, the idea of leaning into the micro-segmentation of networks all the way even down to the device level, and implementing kind of layered access authentication control down to individual network segments, and then just, from policy perspective, kind of driving what that access looks like to enable, some of these drivers. Traditionally, industrial control systems are remain unpatched because it's difficult to do. But perhaps bringing in those service providers indirectly helps the overall kind of cyber posture.
Thank you. This next question will be for Michael. Can you provide one example of an industrial Internet of Things implementation that had an unfortunate cyber outcome, and then what key behaviors or decisions contributed to that outcome?
I told you earlier, I asked a couple of my colleagues for some good stories, and everybody, Stuxnet or something like that. There's a lot of tried and true back and forth. But from my perspective, I think one of my favorite stories is there's a small business that we've worked with that is a DoD provider. They make and manufacture dry goods, dry foods, specifically those that I guess would be readily available to eat in a forward location, not to be too specific. One of the challenges they faced was when you make those things, they have to be pasteurized. You have to get to a certain temperature to ensure that they can sit from an airman's perspective on a shelf for 7, 8, 200 years, whatever it ends up being, before you get to open it up in the middle of a rack. And they found that in testing their system and integrating their network into their production process and the ovens that they specifically used, that you could actually spoof the temperature on the oven to indicate that, yes, it has been pasteurized when in fact it hasn't. So what would happen is it would just rot on the shelf. And that's obviously a problem when you're trying to provide food to a forward location and ensure that you can do it readily. So all the proposals that came out of that from solution providers and from folks in the know, and this is how we're going to fix this. The big one was, we're going to go straight to a digital twin. We're going to build you a simulated system, and we're going to show you exactly where the problems are, and we're going to be able to, everything that the ideal of what a digital twin is, down to the umpteenth degree. And the problem was they couldn't afford it, for one, and two, the paymasters didn't have the ability to fund it at the time. And the solution they came up with was, well, they added an analog dial to the ovens and then put a human in the loop, and put them on clipboard management. And so I think if I could make a prediction about the future, and we talk a lot about at MXD how CMMC is going to impact small businesses, how making sure you're cybersecure at the lowest level is going to guarantee that an F-35 doesn't walk out the door to China, right? It's easy to sell that story, to say, oh, the F-35, and we need to be secure as much as we can. If we don't sell it at the lowest level and find simple solutions for folks, I don't think we'll ever be truly secure. So saying, yeah, I hear you, I want to build a digital twin, it's a great idea, I want to do this and I want to do that. But an analog dial that we then digitized later. We built a system that would read the dial for them and provide some near real-time framework, so they could know, this is what the dial is saying, this is what the digital dial is saying, and this is how they're interacting with each other, so they can make certain predictions on the information. If you can't sell that story at the simplest level without referencing an F-35 or centrifuges in Iran or something like that, we're never going to be secure enough, especially from the DoD perspective, because that supply chain just writ large. The second we involve DLA, how many, 2 million vendors or whatever it is. So that's, I think, my favorite story.
Thank you, Michael.
Yeah, absolutely.
Kind of switching over, another combo answer for Anusha and Mike. Provide one or two real threats that people often overlook, and are there techniques or solutions that are readily available to mitigate those cyber threats? And anyone else, if you want to kind of add in after they're done.
I'll throw mine out there and then pass it over to Michael. So, I'd say the obvious one is really the need for effective authentication of edge IoT. And this has been something that's been, and smart devices, just been overlooked, under-designed. So, I'm sure all of us have probably heard of Mirai, but until about 4 years ago, that idea of a coordinated device attack was really urban legend, right? And then all of a sudden, we saw the chaos that was unleashed on several high-profile services, even Dyn DNS, through a massive coordinated distributed denial of service attack, using simple things like air quality monitors, routers, surveillance cameras. So, this notion of, being able to survive on static password-based techniques just doesn't extend well to IoT at scale. It's not something that is easy to manage or update. And so fortunately, there are a number of emerging technologies that are trying to bring strong authentication to small devices, even given the constraints of power and compute, storage, the whole bit. And what we really need is a next-gen way to support kind of user-to-device and device-to-device authentication. If we really want to bridge this, as Todd mentioned, that, edge all the way back to, the industrial edge, all the way back to kind of the enterprise edge or even the cloud edge. So, a few of the questions that I would say it's important to ask as we're bringing new systems, new vendors, new devices into our networks are really, from the get-go, have they thought about kind of authentication and design that into their systems? What are the user authentication methods that they're using into the device for management, configuration, patching? Does it support things like multi-factor authentication? And then once you've added this device into your network, how do you actually pin access and communication to only this device, right? And guarantee that communication, whether it's in a closed enclave or whether it's in a more hybrid system, is really only happening between trusted elements.
I would say to add to that, from our perspective at MXD, we always start at the lowest level, right? We're always worried about, not what Lockheed needs to do, but really what a small business can do to make sure that they're secure. And I think it starts with awareness, but also with that awareness comes understanding that as you bring new technology onto the floor and it comes with all the bells and whistles, there's also a printer that's been there since 1996 that's hooked up to the network. You have to make sure that's secure. And I think building awareness at the lowest level and also highlighting ways for small businesses to engage with cybersecurity professionals. One of the things that we just produced recently and pushed out was a cyber hiring guide for small businesses, which paints a simple picture on not only where we are today from a cybersecurity professional perspective, but also where we're going to be in the next 10 or 15 years. And I think it's really going to work hard to highlight the use case and the business case for small businesses to make those decisions and say, I can engage in cybersecurity and I can do it at the lowest level and ensure that I'm protected. Not even realizing that as a fourth tier supplier, eventually to DLA, they're actually making the entire infrastructure and the entire network secure. So I think it starts just kind of being aware of what's going on around you and knowing that, you got this new fancy thing and it's hooked up and it's ready and it's safe. And there's a vending machine that hasn't been patched in 5 or 6 years. And this is just sitting there being a vulnerability on your network and allowing access to the open internet. So
thank you. So Anusha, kind of building off your authentication point there, when you look at some of the more traditional risk mitigation techniques, such as whether it's user IDs and passwords or PKI certs and PIN-based activities, those all have a cycle of support, right? Whether they're annual, whether they're quarterly, whatever you need to do to kind of keep that refreshed and controlled. Do you see that kind of as a detriment to adoption? And then what would be an alternative to that?
Yeah, absolutely. I think this is another instance of where we can't really use kind of a stock copy and paste of traditional IT defense over to industrial control cyber risk strategy, really. So, specifically with edge compute, when you're talking about large scale, like you said, Chris, these traditional authentication approaches, whether it's, that static password you put into that admin configuration or a PKI type infrastructure, it's just not realistic. What ends up happening is either they get stale or lead to things like credential reuse, or they're too heavy-handed in the case of PKI and require just this constant management infrastructure if you actually want to get it right. And, I can't imagine being the poor IT person that's trying to manage hundreds of thousands of PKI certificates for some sort of edge sensor network, right, of devices that are going to keep entering and leaving the ecosystem. So, what we really need is something that's lightweight, self-managing in terms of authentication and can handle the notion of ephemeral elements entering and leaving a network. And that's really a must for 5G and IoT. I think we have to take the burden off of the human having to manage and get it right, both from a deployment, but also a sustainment perspective.
Thank you. And I'm going to kind of adjust on you guys a little bit. The next question we had slated for Michael and Anusha, but I think that, Todd and Jordan, as well as Alex, can kind of chip in here a little bit in terms of the, kind of running the themes from a Q&A perspective in your answers. One of the things that I've run into as part of our engagements on IoT is, well, I got really old equipment and it's twisted pair and what are you going to put modern sensors on it? And you kind of get that whole talk to the hand because I just don't have the technology. All my technology is not at the same baseline and I can't do anything until I replace all my tech. But when you look at particularly our organic industrial base, there are national defense assets that are 50 years old. I can pick on the wind tunnels down in Arnold Air Force Base, right? Some of them are actually surprisingly really old, dating back to the World War II in some cases. Still viable, still executing and supporting the mission. But how do we integrate that into the IoT framework, and what tools are there available so we can take those old twisted pair devices and get them into the framework, but keep them secure and generate that value? Who wants to go first? Anusha, Todd? Todd's got it.
I can kind of give I talked a little bit about it earlier when we talk about the edge and the multiple edges, and down at that industrial edge capability. And, a lot of people think it's just gateways down there, doing protocol translation, but the modern industrial edge capabilities includes the, almost like a firewall capability where you can put a hardened industrial edge device that has a secure OS, that has an approved OS, that has, that's part of the enterprise grade infrastructure, and act as that barrier between those, older obsolete protocols and, the serial ports and stuff that you can't necessarily upgrade on your Patch Tuesday, right? So you'll break the control part of it. So instead, as part of that, building the IoT data layer over the top with secure edge devices, that are continuously expanding and having more power. And it's really edge compute rather than just a simple gateway. That's one approach.
Anusha?
Yeah,
Michael?
This is Alex.
Yeah.
Alex, go ahead, Alex. Yeah.
Yeah, I can just jump in. So like you've said, we need, in some cases, we have needs to connect these devices to networks for logging and diagnostics and analytics and whatnot. So in some cases, we can add some kind of an encryption diode in the line where when the output of that diode would be encrypted on an overlaid network and still allow that device to function. Another type of device that we're starting to see in industry is looking at the state that the system is and the state that the usage is in, and only allowing certain types of messages if that system is in the appropriate state. Some of the details of where these can be applied depend on the specifics of those networks and what they're authorized to hold, what kind of traffic and whatnot, even if they're encrypted. And then there's also other programs out there more at the basic research level that are looking at understanding the firmware that's actually on these devices, because you have proprietary firmware, you have firmware, in which the source code is no longer available. And can we extract that while maintaining the same functionality where there's intentional or unintentional, and run some of that logic in a cloud environment, for example? So can we do your lift and shift or whatnot? It's just a couple of the things that we see out there.
Thank you.
And I would add, from my perspective, and it kind of goes to what Michael said about the example of the digital twin for the foodstuffs manufacturing. I think people first need to realize that some of these things are at the top of the cycle. There's more in the buzzword than there is sometimes behind it when you're trying to actually implement organization. But when you and then how do I go about understanding that approach and concept? Then what can I do from it from an outcomes-oriented perspective? Then that informs how I model the world, the tools I adopt, and then the technologies I need to support it. And then I think that framework and approach helps you work in this environment, especially in defense, where you're always going to have something that's sitting, something that's older, maybe archaic, sitting alongside the most advanced technologies in the world. An aside, I worked with an innovation project with some cadets at West Point, and they're trying to solve problems, and they were all looking towards AI or machine learning. And I gave the example of a Moses pole, for clearing trenches. And I'm an infantryman, so this is a dumb infantryman tool. But right now, when you're clearing trenches and you're 100 yards away, observing, and you want to know the forward trace of your guys as they clear the trench from left to right, a big long pole with a chem light on it is still probably the best technology we have, and probably will be for some time. So how does that live right alongside all these other things that we're going to put on soldiers, that we're going to put on aircraft, and everything supporting the battlefield around it? And I think that is very analogous to what's going to happen in factories and maintenance facilities as old technologies continue to provide value. But how do we integrate them, model them, proxy them in this larger system of digital twins and other technologies?
Michael, Anusha?
Yeah, I would definitely plus one everything everyone has said. I guess, it's got to be the underlying premise or the starting point that we do have to support a hybrid architecture, a hybrid set of devices, and some of them are going to be, very shiny and forward-leaning, and some of them are going to have a little bit of dust. And so that idea of creating tiered architectures, kind of enclaves, where maybe you use kind of an edge gateway or edge device to kind of aggregate everything and create a certain security level of everything behind, and then going forward is a really effective way to bolt on security, I suppose, for some of those devices we're going to have to live with for a while.
Michael.
Well, that chem light is certainly cyber secure, right? We can guarantee that. So I think, much like Anusha said and everyone else has said, I would echo that again, saying, we have to consider what works right now and what we need to work in the future, and any way we can integrate those in a way that directly benefits the warfighter, especially, I think is going to be a win, and is going to be something that the Department of Defense and the organic industrial base is certainly going to support. The more we can push forward while bringing those legacy systems, Rock Island Arsenal, there's a Cleveland press. And the reason it's called the Cleveland press is because I think it was made in Cleveland. So, and it's been there since forever, and it works. And if we can put a sensor on it, we can integrate that sensor and make sure it's cyber secure, all the better.
So I'm going to change up the last question on you too a little bit. We're going to start with Alex from an answer perspective, and we'll use it as our wrap up. And it's always that fun question. If you could change one thing about how customers are approaching cybersecurity for smart equipment, what would you change? And I'll start with Alex. All right.
I would say that the bluff is looking at the properties of zero trust networks. Your challenge is on a smart device, you have software, you have hardware, there's going to be bugs, there's going to be insecure configurations intentionally or as a function of applying an update. So there's going to be some unknown behavior, whether you can update that via software. If you look at your Spectre or your Meltdown tools, where fixing it would require firmware or change of hardware or something you can't push out. I would say the answer is looking at your zero trust architecture. So device authentication, user authentication, encryption at rest, and whatnot.
And then we'll move on to Jordan.
Forgive me, there was a cut in the audio when you asked the question, and I came in halfway through Alex's
What one
answer.
thing would you change about how people are approaching cyber for smart equipment? Organizationally or technically, you can pick it anywhere on the spectrum. It's that classic end of the interview. What would you do different, right?
Yeah, I mean, it has to be something imbued throughout people, process, and technology. Leaders who, in the past wanted to say, okay, there's my IT support, there's my cyber support. Tell me what to do, make sure everything works, and then that's the end of my involvement in it. If I'm looking at commanders, people running facilities, shop leaders, they need to get in, understand how it needs to be baked through all the business requirements that they provide that inform these architectures. The days where, IT's over there and business over here are over, and you need to understand the concepts so that you can better work with and articulate and build these capabilities with your IT support institutions and resources.
Thanks, Jordan. Todd?
I think I said it earlier, bolt-on security is no longer viable. It's too cumbersome, too many different vendors. It needs to be deeply embedded into everything we do. It needs to be software-based, code inspection is built in there, and orchestrated centrally. So the cloud, secure cloud, is going to play a big portion, a big role in that. But really, it has to be done, from within and not just bolted on.
Anusha.
Yeah, I mean, I would say, to me, cyber is not a point-in-time thing. It needs to be, when you bring in a new architecture, a new device, a new system, one of the important questions is, okay, what is the sustainment leg from the perspective of keeping the cyber guarantees I have when I set it up and turn it on the first time? What does that look like, both from a people, process, policy perspective? And as much as possible, making these systems kind of self-assuring, and choosing systems that are self-assuring from a cyber perspective, so that things like authentication are dynamic, not point in time. Things like encryption are kind of self-rotating, if you will. So all of those notions of having cyber be a continual aspect of the system and operations is I think, crucial.
Mike.
I would say it comes down to the policy side, right? We need an integrated policy across the OIB and I would say the defense industrial base as well, that allows for the engagement and integration of digital technology on the factory floor, and allows for next-gen communications to be integrated as well. And I think on the policy side, we need to make sure that those improvements and innovations come from the lowest level, and that there are mechanisms in place to allow a young airman to fix the air forward chain. Because right now, the next great idea sitting at the A1C level is going to be snuffed out by an unintegrated IT and OT policy across the board.
Thank you all. So with that, we're going to wrap up our panel. I really like to thank all of you for taking time out of your busy schedules. And it's not just this panel, but it's also all the prep work that all of us put into it.